Well, day 9. Streaming, or not streaming, working on Godot stuff. Alrighty, time to do the learning thingy, my bobber. You know. Do the learning.
Welcome to another tutorial on isometric tile maps in Godot. Now, in the previous 2 tutorials, we've been making use of a asset pack from Canada now that has a different sprite for every tile. Sometimes though, you're also faced with tile sheets, a little bit like this one. Now, that works a little bit differently, and at the same time, it opens up the opportunity for auto tiling and atlas tiles. So let's have a look at that, how we can make a tile sheet into a tile map, make it look great, and make use of those features. Well, let's get started. Now, for this tutorial, I'll be making use of this Grasslands tile sheet for clean blender uploaded over gamer.com. You can use this commercially in your project if you so desire, as long as you have the proper attribution to the artist according to the license. Now, this is a tile set that uses 64 by 32 base isometric grids. That's important for our sites in Godot. When you scroll down here, you got the Grasslands tiles.png right there. If you download that, you get something like this. Now, make sure you drag this into your Godot project folder so you can access it in your Godot editor. Now, when you're in the Godot editor, let's look at how to set it up. Right here, I got a tile sheet example to Node 2D. So we'll be making a tile sheet example, add a tile to a tile map. I've already set the mode to isometric. I've already set up the cell size 64 by 32, just like Blender set in the description. Now, when we actually want to create this tile map, we're using the tile sheet. You can go to the tile set and go to new tile set. When we click on that, the tile set editor will appear. You may not make this video, depending on the button on the right or down here. So, you might want to like this, you may like this, and you probably want to do some workspace in tile set editor. Now, the tile set right here, you see that drag Grasslands tiles.png into this full location, and you drag this to this area right here. When I do that, you import PNG file as tile set. As you can see, I got
I guess I could expand it. Well, at least it's good to know. Good to know.
We do that first using tile select and level. The moment you do that, this snap option also doesn't just click snap right here. When we set snap, which is snap, of course, the tile set being 64 by 32 grid. When you do that, you see we actually exactly start selecting the tile set 1. So now I select this tile, I was pressing using tile, press another one. We now create 2 tiles, select 2 regions, we do this tiles with our tile set. Now we go back to tile map, you'll see those 3 mass tiles now available for us to select and draw. And as always, you use up on top and pencil drawing tiles. Now you probably don't use it like this, but when you have this tile map, you make a sheet, you make use all the time. So let's do all the time next. Do you want to run games? Do you want more? So I just don't look at the bottom. Also, there's something that I'm actually going to search the link to the next box. That's neat. And start all the time using the grass. Because they're all tiles to share every tile. So by right click, delete tile right click, and we'll go back to the tile set editor and select tile sheet. And we'll delete the trash here. No longer needs. Now let's set all the time. We select all these grass tiles. Now use all of this example. You can example this tile. Now all the time before extract right here. I'm using all these features. Also, I'm going to use tile for something. I'm going to use certain tiles are not for you to use that. For priority something funny. For priority switch. Long list of you can if you want tile set now, you want to use all those use the right here. You can change how all tiles is on deviate the tiles you use. And lastly, you have this which tiles you can connect together. Basically, that's exactly what you do. And basically, so we can use this match that format use of course. So basically, this tile will be underneath here. Basically, from this area right here. And by using this right here, we can connect this right here. So that connect and then all tiles know that you can use together. So with that, we like to tile using one grass tile right here now. Because that's what all tile and we have that's all. We can call these tiles and we can see now actually grass tiles now. Now grass looks repetitive as used to just especially when adaptations of this tile will transfer to that. Now for demonstration, we make a little bit piece. It's not going to change this grass tile system. What we do next, we'll make a nice font. So I will fill up that video. Now let's adaptation this and we adaptation on demonstration of the tile. So that the all time goes back to tile set. You can see right here the call adaptation. So adaptation of the 64 that's all. So that's the and that's like regional tiles and regional tiles and regional tiles. And for this tile 64 that's still as long as that's tile size that's 64 so the tile knows how to draw out different tiles from this regional tiles. And also like I said, use example these tiles. And also you also set name with all tiles and grass tiles. But first time we go with let's go back to the example. So we have to tile. Now you see like when I click that it all here on top. That's all the tiles that the tiles from being selected. Now we're happy to will see we're now removing tiles to the same tiles. We're renaming this to grass tiles and we tiles that's will need to and the tiles focus on 64 and with the ground tiles we tiles editor save these to review the tiles editor you can see save as and save for resources and save it as the example sheet tile sheet example 7 so then we go back to professional and I'll set the first one to new tiles and load tiles save resources tile sheet example but that's the we see all that's very select and drop it's on that you see also it's wrong just below tiles we have resources so you see the is wrong one tile below so it's that these tiles editor you're going to read and that's the offset is 1.2 so height one tile now that's you see I'm drawing second tile that's our mouse over you see the height tile over it so we have to make our wish about the more trend level font so that's what we want to look at the also again you want to look at the of and show you how ordering when I'm going to draw both the next one in so now we're going to go to the tile sheet editor and first what tiles are right here the tiles we're getting more tiles like all tiles that's like that's we want to so and we just tiles we set aside and these to water control with that we go back to run grass water and we run a little on you see the brand new changes
I feel like, yeah, that's like 3.2. I feel like I see none of these options at all when I do my tile setting. Which I guess is fine. Same concept. How did I make the slime? I want to just like make an animated sprite. I did a sprite frame. I think I just drag, click here. I think I hit this thing. Go to assets, isometric, TRVG, and then entities. I don't know what these are. This is not 4x4. Is this 1x1? It's not 1x1. Oh, I'll go until it looks right. Like that. That looks right-ish. Alright, so I have my frames. attacking. Enemy. TRPG. No, this has a raycast on it. So it's a collision. So it's a kill zone. I can add the kill zone. Or I can attach a. Nope, that's not it. Collision shape. Sword-ish. Let's attach a script to this. Then take the basically yoink this. Oh, it's named the same, so it's fine. Alright. Now, let's try to drag this little guy. Gar, 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 gar. Gar. Oh, but he turns. Oh, is there a way to flip the collision? Focal position. Let's see. I want to flip this guy, this collision, into the sword. Or maybe I could turn it on and off. Oh, that's wait, let me try that. Maybe that's a thing too. Hold up, let me get it. So, collision shape 2D. Let's grab another one. Okay, well that's a little. Okay, let me just dupe this. Move that over. Collision shape right. Collision shape left. Let's go to my script. Let's drag. So this is so right is flipped. So collision shape, which starts disabled. Collision shape left is disabled first. Goes true. Is that how that works? This is probably not the best practice, but whatever. Invalid assignment of disable with a type on a of type nil. Okay, well. I need to like set. What set deferred? Disabled. True. Collision shape. Okay, I have to do set disabled. That's all. Right, and then when I hit, this is my right. So then I disable. So I enable. Shift tab, which is a weird, but whatever. Invalid. Wait. What the hell? Wait, so I set it to true. Wait, which was on first? My left one isn't turning on. Oh, this gets set every time. So what, on the first case? Wait. Okay, this hits on, this is called every frame. Oh, that's why. That's very... So let me drag another... Let me see what you do. Because this should go on infinitely. Okay, yeah, both of them are on. It's definitely not what I want. This only happens if it collides. Okay, you know what? Actually, I can do this. I'll do this. This is better. So if direction is equal to 1, then I will move this. Now this should work. If he doesn't collide and he just keeps on walking to the right, this should work. That's to the left. Oh, I had it flipped. Take that little snot. So now if I like... No. Oh, I can actually just... This is a node, static body 2D collision shape. Oh, interesting, okay. Let's try it. So, a static body 2D, and then add a collision shape to it. Polygon. And I'm gonna add... a line. Huh. Yeah, you could just add like a border. Okay, let me expand my grid a bit though. This guy's here. myself more room to play with. These have collisions, right? I don't see collisions. That doesn't really make that much sense, but whatever. Whatever, buddy. Just messing around right now. Let me pull this camera out a bit more so I can see more of the world. It's like how do I go to deleting? Oh, there it is. Erase points. Ooh, ooh. Let's add some points. Can I like invert this? Segments? Is that how that works? I feel like that's not how that works. Let's just see. I should erase them. Alright, let's see. I think this. Okay, this is. Ah, so that's how you would do it. It's like making a little box. What? What the hell? I like that. Okay, now it works. Is it because it's over? Like if I do it like that, is it cooked? Oh, it's this geometry bit. Oh, I see. But like this, like a little. I need to increase my speed. Like, damn, bro, you slow as hell. Let's double the speed. Quadruple? What the hell? Oh, this is the wrong guy. Wait, what? Yeah, I'm on the wrong guy. I'm supposed to be on this guy. it's like. Hey man, why am I so slow? Wait, isometric. Wait, what is this? Who is this? Is it not this? I have to flip this. Let me get rid of like a UI. Actually, I don't think I'm on the right. This is not right. This is not right either. Because I added, it should be this one. And let me turn off the flip. Yep, it is this one. Is it because my max speed is here? Am I even using speed? I think I tried getting rid of it. Just like, does it break? Oh no, it doesn't break.
Active coalitions on your tile map will basically be making sure that your tile map coalitions are doing something based on player input. Let's quickly have a look at the example of this tutorial and the specific challenge we'll be addressing. After that, we'll dive straight into the video. So this is the project we'll be working with. We got a river with water slides, and those water slides have coalition shapes on their tiles within the tile set. Now, we can't enter the water because of these coalition shapes, but these coalition shapes are also limiting us from accessing the bridge. And of course, we want the players to be able to cross the bridge. That's the challenge for today. Let's get into it. So to start it off, let's first have a look at the bridge and how we can build the trigger when the coalition shape on the tile map has to turn on and off. So the bridge is an inherited scene or an instant scene from another scene. That will be this scene. Now, this scene is set up quite specifically to make sure that the draw order of all the textures is in line to make sure that it looks good on the map. I'll get into how I exactly did that at the end of the video. Let's first make sure that the coalition shape on the tile map is interactive. So on the bridge, we have two coalition polygons, both which are there, basically keeping us from walking the river once we're on the bridge. They don't have interesting reasons that, and that's just items that are going to distract us. Now on the bridge, I'll be area 2D. So area 2D is going to be detecting coalitions or detecting other bodies that are entering this area. I'm using a coalition polygon to draw this out. Now what I'm doing is I'm basically selecting or drawing the area where the player is able to walk. This will not create the ability for the player to access this area, but we will require information when the player is on the bridge and when the player is off the bridge, and therefore I draw the area where the player can walk. Now with that area in there, we need to make sure it triggers when something enters. So to do that, we're going to go to the area 2D. We're going to go to the nodes, and we'll be connecting body enter and body exit functions or signals. However, we can only do that to our bridge has a script, so we first add that. So with the bridge script selected or added, we go back to the area and we're connecting those two signals up. There we go. Now the thing is that these signals, they will hit as soon as a collision that they can interact with enters this area 2D. And the thing is that underneath this area 2D, there are already collision shapes when the game starts. That's a collision shape of the tile itself. The collision shape, the very collision shape is actually turned off. So to make sure this area 2D cannot interact with collisions of the tile map, I'll be making sure this area 2D in collision unit inspector is not on layer 1 where the tile map is. We're going to put in layer 2 to make sure the player can interact with this. We also have to make sure that on the player scene, on the player we set collision to 2. Of course, we'll also keep it in number 1, so it can keep interacting with the map, but we also want the player to interact with the area 2D of the bridge. So that's how we set up. So we can say this, we can say that. Now on the script of bridge, we now receive these signals. So we now have to build the function somewhere where the signals are taken and are going to be directing the turning on and off of the collision shapes on the tile map. However, we do not want to do that code here on this bridge because every time we copy bridge into the bridge somewhere else in our game, we'll just be copying all those lines of code and just add more drag and more stuff to our game more than necessary. So we prefer to have one place where we put the function that's going to be handling the turning on and off collision shapes, and we'll use this script to just pass through these signals the area 2D gives. So this script is not going to be a messenger. So you receive signals and he's going to send out new signals. So we two new signals, and just to make it easy, it's going to be the signals to turn off the water cliffs and the signal to turn on the water cliffs. Now in here the function by enter, that means that something entered the body, so something came on top of the bridge. When something is trying to get on top of the bridge, then we're going to turn off the collision shapes of the tile map that are on you. So we're going to say even signal, and we turn off the water cliffs. And of course we do exactly the same on the rest of the other one. As soon as somebody exits the bridge, we turn those water cliffs collision shapes back on to make sure that we can't get over the bridge, walk around and get into the river. So this is our messenger script where it's taking the signal from the area 2D, he's pushing the turn on water cliffs into the rest of the game. Let me connect that somewhere up. So yeah, that's into that. Before I do want to explain one thing on area 2D. As you see, I've drawn this out a little bit further from the bridge. I'm not exactly hitting the shape of the bridge. I'm a little bit beyond. The reason why I do that is that when the player approaches, you know what? When the player approaches, let's say that the collision shapes of the tile map underneath are exactly equal to the bridge. They're probably not, but imagine they are. The different thing is the moment this player hits this area 2D, and then collision shapes have to turn off. If you turn on collision shapes, or if you build a collision shape, that always happens one frame later. And when that happens one frame later, you might get a little bit of stutter, a little bit like drag, a little bit like lag to the player. So I want to make sure that at least one frame between the player hitting the area 2D and the player hitting the collision shape of the tile map underneath. So the collision shape on the tile map underneath has enough time to turn itself off. So that's why I had these two sort of extra areas or extra extensions. That's the so the rules player, you know that. Let's get into the next part for connecting signals. Do you want to learn how to design the game? Or maybe just learn more about Godot? Subscribe to the channel and don't forget to hit the bell icon to make sure you get out videos. Also, if you're curious about getting into the project myself, we go to live streaming sessions every Tuesday and Thursday. The link in the description, all that down in that description box below. Now let's continue. Now to connect our signals up, we don't want to connect signals up one bridge at a time, or we can do it in one bridge at a time. But we want to look through all the bridges at the same time if we can. And the way we can do that is when we add this bridge to the main node, when we add it to a group. That's all we do. We're adding to a group of bridges. That means that automatically every single instance that I make this bridge will be in a group of bridges. Now when there's all in a group of bridges, we can go back to the map. Down the main map node as well, we'll be adding the script of our map. So this is going to be handling. Under here, we're going to say on the function already. Function ready? Yes. We're going to say for bridge in. And we get the entire tree all nodes. And we're going to get all the nodes that are in the group bridges. When everything's correct. There you go. Now with that, we're going to have basically an array of nodes, and in an array are all nodes that are in group bridge, so we have a bridge like that. And we're going to bridge on connecting a signal. Now we first have to say which signal do we want to connect up. Let's start with the turn off the workplace. So we'll say, let's say where we want to connect it to. Well, we want to build the functions for turning on and off the layers on this script, so we're going to connect itself. Then we just say which function has to play, which function has to activate the moment this signal is received. Well, let's not be creative here, and let's just call our function turn off workplace. That means of course that we need to have that function. So here we're building the function turn off the workplace. We'll just put it as there. Now we're going to do exactly the same, but then with the signal turn on the workplace, and that's going to be activating the function called turn on the workplace. Or using maybe to paste this and just replace off and on there. So now we have a function that's time to, or actually, yeah, we have activation functions, and build this function. Let's do the next one. So to build this function, let's first have a look at the actual town map, the actual collision town map, and what we can do with the parameters to make sure that they're not interacting with them. So the workplace are here on this town map. You can see when I turn this off, you can see all the workplace are disappearing. So in the inspector, you'll see that this is also a collision layer and mask, just like the layer in the area 2D we're filling around with just a moment ago. So what we have to do, we can turn off this layer into mask, thereby the player won't be able to interact with it because it's not basically in a layer anymore. So to do that, you have to, so you'll see that layer 1 is bit number 0, and that's just the zones as I defined before, and this is layer 20 bit 19. So you have to call these collisions layers of masking code. For code, they are in an array that starting with 0, but the layer starts with 1, so it's a little confusing, but that's something to look out for. So what we'll do in the script is when we get to turn off the workplace, what we need to get is node workplace. We need to reference that a couple of times, right? So it's easier to say already creating a variable and make sure this variable is defined along the script, or a node essentially, and we'll just say a workplace is get node, and then we'll get the workplace. Like that, we can now reference this node by just using the variable, and we can say a workplace. We want to set the collision layer bit, and we're going to set bit number 0 later on, and we're going to set false. We're no longer active. We're going to do exactly the same with the workplace. Set collision mask bit, turn that one off as well, and that will be false too. And we do exactly the same on here, when you turn on workplace, but then set false, we'll be saying you are true. And that should create the behavior that we want. Let's check it out. So here we are, we've got the collision shape. We still count as the river, but as soon as we hit area 2D, collision shape turned off, that won't be visible in the editor, but now you can cross the bridge. And just like that, we have created an interactive collision layer on our timeline. Now there's one problem though, because this collision area 2D, I should say, activates when anybody entering it, whether it be an arrow, or projectile, fireball, a gun bullet, a grenade, or an enemy. And what we have is the player's fighting, and then he finds himself after the battle in the river, we have to lose the river. But as the battle is over, all the enemies are dead, all the projectiles have flown past the bridge, and now the player can't get out of the river, because that collision shape's turned back on. So we want this area 2D to activate when the player enters it. All we need to do is make sure that it activates when enemies anything cross, but they want to do everything in the place. It's possible to appreciate that. Let's make sure that we work making sure that area 2D only activates based on the player entering. For that, we're back on our bridge script, where we have signals. I want you to do this sort of this check whether the signal should be is a player. Do that as early as possible. The reason why is that you get signals being passed in your game to all kinds of nodes, all kinds of processor capacity being used for signals. So you better make sure the signals are not sent as early as possible. Thereby you create as little drag for the processor as possible. So what we do now is basically this code. So instead of just emitting the signal, we're going to say if nobody's player, we first have to define player. Just like we have defined the workplace earlier, we're now going to say okay, on ready. We have a new variable, that's all player, that is equal to get node, and this player is actually a little far away. There's a little bridge right here. So what we do, we get the parent of the bridge. We get the parent of that, that's y sort. And in y sort we'll find the player. Now we do get parent get nodes, 3 functions after each other. What we also do is do double dot. That's the same get parent, do the double dot. That's the same as get parent, and then we're going to get the player. Of course, it needs to be in quotations, and now we have the player node C on the player variable. We'll just close the bracket. That makes sure it doesn't error out anymore. So we're going to say that area 2D, that the signal is being sent by area 2D, that also brings us the body that's standard in this function. And the body is actually no reference to the body that actually enters the area 2D. It's the same with the player. So we're going to check if the body is the player, and we first check if we're doing if not, so we'll reverse check. If the player or if the body is not a player, then we do nothing, and else emit a signal. So that means we turn that away, and we pretty much copy and paste that in there. All we have to do is make sure that this is going to be emitting a signal, turn on workplace. And just like that, we make sure that area 2D only reacts with the player and nothing else. Now I promise you, I'll also show you how to make sure that the draw order of this bridge in such a way that it looks neat. And does it really need us to look at that? So we're going to do how does area 2D now really need that currently. So I'm going to say that on the tile sheet, actually, you have to turn the visible collision shape as well. Let's have a look. This map is drawn in such a way when I stand behind the map, you can see my feet are covered by the bridge, I'm standing behind the bridge. And when I walk this line, it's hard to see, but I'll be covering the actual side of the bridge. The character is walking over the bridge, I'm standing in front of this railing. So you walk sort of around the bridge there. But at the same time, this railing is covering his feet. So it looks very good in here, it's covering in front here. Now there's a very specific way how you can do this. I'll show you how. Before I do have to get my thanks to, I believe it's creator of this bridge. I'll put a link down in the description where you can download this art set. It has 8 different directions that also comes with a bridge. It's very beautiful art you can use in your game. It's free to use commercially under the CC BY 3.0 license. So get that if you want to, and make sure you reference him and give him the attribution that he deserves. So how we done that? Well, actually we are able to do this thanks to Bleed and what he provides. So first of all, of course, you can already saw that the bridge is laid in nested Y sort. So Y sort is making sure the draw order between the player and all the elements is being done based on the Y axis coordinate. So if you want to learn more about that, I have an episode on Y sort and how you can make awesome matches. Maybe watch that one if you don't understand what Y sort can do. But I'll show you now how exactly set the bridge. So on the bridge, you can see the Y0, I position this bridge exactly where it's the walkway starts. Just make sure when the player is behind the bridge and his Y coordinate is higher, he's drawn behind this bridge. But as soon as he crosses this Y0 line, which of course will be the case he's walking on the bridge, that he's been drawn in front of this bridge. Of course, it gives a problem because it also means he'll be drawn in front of his railing. Now, what Bleed, the creator of this art set does, he actually also gives you a PNG image or a JPEG image of the railing itself. So the railing itself, I've set the Y0 not to be at the back end, but to be at the front end. And in the map, there's actually 2 nodes in this bridge because this railing is just a copy on top of the original bridge. However, the Y sort of the railing, I put it right in the right spot. The Y sort of the railing is in front of it, just moves is right there, and the Y sort Y0 of the bridge is at the back end there. And that creates that the character can able to stand in front of this railing at the same time behind this railing. Because they're actually not the same images. That's how the draw order make sure that this bridge feels very real and creates the exactly kind of visual drawing that you want to have in your game. So good luck drawing that. Get over to the Bleed site and make sure to get that pack. It's awesome art and it has a lot more. Okay, that was it for today, guys. Hope you like it. Do smash that like button, hit subscribe, don't forget that little icon to make sure you don't miss out on the next video. Also, again, if you're curious about the game that I'm doing myself, head over to Hey guys, welcome to another tutorial. In this tutorial, we're going to take a look at interactive collisions on your tile map. We're basically making sure that your tile map collisions are doing something based on the player input. Let's quickly have a look at the example of this tutorial and specific challenge we're addressing. After that, we'll dive straight into the video. So this is the project we'll be working with. We've got a river with water slides. Those water slides have collision shapes on their tiles within the tile set.
What? What are you yapping about? What are you yapping about?
set. Now we can enter water because these collision shapes are also limiting us from accessing the bridge. And of course, when we play across the bridge, that's a challenge for today. Let's get into it. So to start off, let's first have a look at the bridge and how you can build the trigger when the collision shape has on timer as to turn on and off. So the bridge is an inherited scene or instant scene from another scene. That would be this scene. Now this scene is set up quite specifically to make sure that the draw order of all entries is in line to make sure that it looks good on the map. I'll get into how I exactly did that at the end of the video. Let's first make sure that the collision shape on the timeline is interactive. So on the bridge, we have two collision polygons, both which are there, keeping us from walking the river once we're on the bridge. The other very interesting reason that, and that's just how to distract us. Now on the bridge, I'm going to area 2D. So area 2D is detecting collisions or detecting other bodies that are entering its area. I'm using a collision polygon to draw this out. Now what I'm doing is I'm basically selecting or drawing the area where the player is able to walk. This will not create the ability for the player to access this area, but we will require information when the player is on the bridge and when the player is off the bridge, and therefore I draw the area where the player can walk. Collisions on your timeline, basically making sure that your timeline collisions are doing something basically very good. Let's quickly have a look at the example of this tutorial and specific challenge we're addressing. After that, we'll dive straight into the video. So this is the project we're working with. We got a river with water slides, and those water slides have collision shapes on their tiles within the tile set. Now we can enter water because these collision shapes are also limiting us from accessing the bridge. And of course, when we play across the bridge, that's a challenge for today. Let's get into it. So to start off, let's first have a look at the bridge and how you can build the trigger when the collision shape has on timer as to turn on and off. So the bridge is an inherited scene or instant scene from another scene. That would be this scene. Now this scene is set up quite specifically to make sure that the draw order of all entries is in line to make sure it looks good on the map. I'll get into how I exactly did that at the end of the video. Let's first make sure that the collision shape on the timer is interactive. So on the bridge, we have two collision polygons, both which are there, keeping us from walking the river once we're on the bridge. The other very interesting reason that, and that's just how to distract us. Now on the bridge, I'm going to area 2D. So area 2D is detecting collisions or detecting other bodies that are entering its area. I'm using a collision polygon to draw this out. Now what I'm doing is I'm basically selecting or drawing the area where the player is able to walk. This will not create the ability for the player to access this area, but we will require information when the player is on the bridge and when the player is off the bridge, and therefore I draw the area where the player can walk. Now with that area in there, we need to make sure it triggers when something enters. So to do that, we go to area 2D. We go to nodes, and we'll be connecting point enter and point access functions or signals. However, we can only do that to our bridge. Our bridge has scripts, so we first need that. So with the bridge script selected or added, we go back to the area and we're connecting those two signals up. There we go. Now the thing is, bridge on area 2D. So area 2D is
Alright, let's just make a bridge. Let's do like we'll make like a landmass. Radio. Then let's do like wall. Right, so I can't collide with these. Now let's make a bridge. Make a bridge. Make the bridge. Get rid of these ones. Let's make a bridge. Actually.
detecting collisions or detecting other bodies that are entering its area. I'm using a collision polygon to draw this out. Now what I'm doing is I'm basically selecting or drawing the area where the player is able to walk. This will not create the ability for the player to access this area, but we will require information when the player is on the bridge and when the player is off the bridge, and therefore I draw the area.
So he has a sprite. Actually, okay, those are not ISOs though. Wait, what did I use for my player? Entities? Outlined entities. That looks like it. That looks like an outline entity. Oh yeah, it's an outline entity. Okay, well, I don't have great. I could just like throw one in here. Ubba. I was thinking of making one, but is there a good way to make one? So what I could do, what I'm thinking about is let's grab this. We'll call this like bridge. Some oblui. And then we'll do like, I don't know. Like this one. We'll do the half slab. Can't see the half slab behind it though. Sure. What area 2D? So I can't walk to the left and right of it, but I can walk on top of it. So if I enter, I'll be like, how the hell? What the heck, brother? Why am I going under it? Why am I going under it? Why am I going the I going under it? What? The heck? Am I going under it? Am I going under it? I don't understand. What is this layer? This has nothing in it. Now I'm going. Why is this? What? Okay, whatever.
Area with more. Now that area in there, you want to make sure it triggers when something enters. So to do that, we're going to area 2D. We're going to nodes. How we connect import enter import access. The functions or signals. How do we do that? To our bridge has a script, so we first add that. So with the bridge script selected for edit, we go back to area and we connect those two signals up. There.
Body, child, tree exited, child, or it's area. Oh, area.
There we go. Now the thing is that these signals will hit as soon as a collision that they can interact with enters this area 2D. And the thing is that underneath this area 2D, there are already collision shapes when the game starts. That's the collision shape of the town itself. The collision shape is every collision shape right now. So to make sure this area 2D can interact with the collision of the town now, I'll make sure this area 2D in collision in this vector is not on layer 1 where the town is. We're going to put in layer 2 to make sure that the player can interact with this. We also have to make sure on the player scene, on the player reset collision to course also be in the 1, so it can keep trying to do that, but also on the player interact with the area 2D.
Does that mess with anything? It wasn't on collision 1.
Bridge. That's how it's set up. So we say this, we say that. Now in script of bridge, we now receive these signals, so we have to build a function somewhere where it's going to take and directing the turn on off collision states all the time. However, we do not want to copy all these bridge because every time you copy bridge into the bridge in the game, we'll just copy all those lines of code and more drag and more stuff to our game when that's necessary. So we currently have one place where we copy functions that we add in the turn on off collision, and we'll use this script to just pass through these signals to various users. So this script is not going to be necessary. So you receive signals and then send out these signals. So we two signals, just like easy. It's going to be the signals to turn off the water clips and the signal to turn on the water clips. Now in here, the function by enter means something entered the device, something came on top of the bridge. Once something is trying to get off the bridge, then we'll turn off the collision states all the time back down. So we're going to say easy signal, and we turn off the water clips. And we'll do the same on the rest of the as soon as somebody exits the bridge, we'll turn the water clips collision back on to make sure that we can't get over the bridge around again. So this is our message script where it's taking the signal from the RGB, he's pushing the turn on water clips into the RGB. Then we can connect that somewhere else. So yeah, before we do want to explain one thing on RGB, as you see, I draw this out a little further from the bridge. I'm not exactly hitting the shape of the bridge. The reason why I do that is that when the player approaches, you know what? When the player approaches, let's say the collision shapes of the tile map underneath are exactly equal to the bridge. They're probably not up and down. The different thing is the moment the player hits this RGB, then that collision shape turns off. If you turn on collision shape, it always happens one frame later. And when that happens one frame later, you might get a little stutter, a little bit like that. So I want to show that at least one frame between the player hitting the RGB and the player hitting the collision shape on the tile underneath. So the collision shape on the tile underneath has enough time to turn itself off. This is why I had these two sort of extra areas or extra extensions as the use. So the rules player, you know that as the next part for connecting signal. We do know how to design the game, so we're using the Godot to the channel, make sure it's how to use. Also, if you're using the project myself, I'm going to live stream the session, choosing the link, the channel description, all that down in the description box below. Now, to connect signals up, we only connect signals up one bridge at a time. Okay, we do it one bridge at a time. We want to look for all the bridges at the same time if we can. And the way we do that is when we add this bridge and name nodes, when we add to a group, that's what we do. Adding to a group. That means automatically every single instance that makes this bridge will be in a group bridges. Now, when there's all in group bridges, we can go back to name map nodes as well. We add the script format. So this one can. On here, I'm going to say the function array. Yes, I'm going to say for bridge in. And we get the entire tree all nodes. And we get all nodes that are in group bridges. There you go. Now with that, I'm going to have basically an array of nodes, and we iterate all nodes that are in group bridges. We're going to do that. We're going to connecting a signal. We're first to say which signal we want to connect off. Let's start with the turn off the water clips. So we'll say, let's say, when we say where we want to connect it to, well, we want to build a function for turn on off collision layers on this script, so we connect stuff. Then we say which function has to play, which function has to activate. The moment this signal is received, well, it's not created, let's just call our function turn off water clips. It means we'll have that. So here we'll do the function turn on water clips. We'll just put it as that. Now we're going to do exactly the same then with the signal turn on water clips. That's an activating function called turn on water clips, or you may use this and just replace off with on there. So now we have functions on to actually activation functions and build a function as the next part. So the build function is first look at the actual time map, the actual collision time, and what we do is make sure that they're on the transfer. So the water clips are here on this time map, and see what turns off and see all the water clips are here. So in this factor, you'll see that this is also a collision layer and maps like clearing the RGB, we're clearing out this window. So what we have to do is turn off the layer that's masked, thereby clearing the RGB because it's not really in the layer. So to do that, we have to see the layer 1 is being on 0, and just change on to 0.54, and this is layer 20, 90, 20, all these collisions layer masking code, and for all the layer starting 0, the layer starts 1, so usually that's what we have for. So what we do in this script, and when we turn off the water clips, well, we get this no water clips. We do that a couple of times, right? So it's easier to make on creating variable, on making sure this variable is defined on the script, but a node is usually, and we'll say water clips is get node, and then we'll get the water clips. Like that, we now reference this node, want to use the variable, we can say water clips, we want to set the collision layer, and we set the 0, layer 1, and we set false, we're no longer at. We're going to do exactly the same water clips, set collision mask, we turn that one off as well, and that we false too. And we do exactly the same here, we turn on water clips, then set false, we say you true. And that should create the behavior that we'll let's check it out. So here we are, collision, we still trying to deliver as soon as we get collision turn off, it won't be visual in the editor, but now you cross the bridge. And just like that, we have created an interactive collision layer on our timeline. Now there's one problem, this collision carries the actually activates like any enter, like an arrow, projectile, fireball, gun bullet, grenade, or an event, and we have to play fighting, and then he finds himself after that the river, but as that was over, the enter that all the projectiles flown past the bridge, and now they found out that collision shapes so one carries the activate on the player engine. All you do is make sure that activate line is anything across, they will do everything. It's also do bridge figure out. Let's make sure that we make sure that the only activates based on the player engine. For that, we're back on our bridge script. Where we send I want you to do this sort of check whether the signal should be is there. Do that as early as possible. Reason why it's actually being casted in game to all kinds of nodes, all kinds of processor capacity you use for signals. So you better make sure the signal is sent as early as possible. You create a little driver processor as possible. So what we do now is basically code. So instead of just emitting the signal, we're going to say if nobody's player first has defined just like we have to find the wireless earlier, we're now going to say on ready. Then the variable full player as equal to captain nodes, and then this player is actually far away. There's a little bridge right here, so we need the parent of the bridge. Then we get the parent that is y sort. And y sort will find the player. Now we do the parent nodes, three functions after each other. We also do the build up. That's the same as the parent, do the build up. That's the same as the parent, and then we're going to get the player. Cool, that needs to be quotations, and now we have the player node C on the player variable with the color red. That makes sure this one more. We're going to say that RGB, that the signal being sent by RGB also brings up the y standard function. And y is actually no reference to y actually acting RGB. It's the same with the player. We're going to check the y of the player. When we first check it, we can reverse check. If the player is not there, then nothing else, you make a signal. So that means you turn that away, and pretty much copy and paste that in there. All you have to do is make sure that it's going to be signal turn on words. And just like that, we make sure that RGB only reacts to the player and nothing else. Now, I promise you, I will show you how to make sure the small order is bridged in such a way that it was neat. And let's really need to look at that. So we're going to do how does RGB need that currently. So I'm going to say that on the tile sheet, actually, we're going to turn visible collision as well. Let's have a look. This map is drawn in such a way when I stand behind that, you see my feet are covered by bridge, and I'm standing behind the bridge. I know this line is hard to see, but I'll be covering the actual side of the bridge. The character is walking over the bridge, and I'm standing in front of this railing. So we'll sort of around the bridge here. At the same time, this railing is covering his feet. So it looks very good in here, starting from there. Now, there's a very specific way how you do this. I'll show you how. Before you do that, you have to get like links to leads to the bridge. I'll link down in the description where you can download this RSet. It has 8 different directions. It also comes with bridge. It's very good for using your game. It's free to use commercially under the CC BY 3.0 license. So if you want to, make sure you're referencing the attribution that it uses. So how you know that? Well, actually, you're able to do this thanks to Glee and the web commands. So first of all, you can already saw that the bridge laid in S Y sort. So Y sort makes sure the draw order between player and all elements is being done based on the Y axis coordinate. So if you want to learn more about that, absolutely Y sort how you make all the matching. See which one you want to I'll show you how I can the bridge. So on the bridge, you can see the Y0 Y position is the bridge exactly where is the wall base starts. Just make sure that when the player is behind the bridge and his Y coordinate is higher, he's drawn behind the bridge. As soon as he gets across this Y0 line, which corresponds to walking on the bridge, that he's being drawn in front of the bridge. Of course, here's the problem. That also means he'll be drawn in front of the railing. Now, what really the creator of the he actually also gives you a PNG image or a image of the railing itself. So the railing itself, I set the Y0 not to be at the back end, but to be at the front end. And in the map, there's actually two nodes in the bridge. The railing is just a copy on top of the original bridge. However, the Y sort of the railing, the Y sort of the railing is in front of the move is right there, and Y sort of the bridge is at the back end there. And that creates that the character can take 0% in front of this railing at the same time behind this railing. That's actually on the same bridge. That's how the draw order make sure that this bridge feels very real and creates the exactly kind of visual drawing that you want to have in your game. So if you want that, there will be links to make sure you get that pack. It's not already have a lot more. Okay, now this is what I do. Smash it like hit it so I don't get a little like to make sure you see if you like want to eventually restrict somewhere that we patch on the computer. Feel free to get that source. We also get that now.
Okay, it's a little odd. I think it's gonna work too well in this scenario, but it's fine.
In this tutorial, I'll teach you how you can make single tiles in your time interactive, and at the end of the video, I'll teach you how you can replace single tiles at one time while you're playing your game. Let's start. Now, on our map, we got a couple of chests. 5 of them are closed, 2 of them are open. At the end of this tutorial, we'll make sure that these tiles, which are the tiles set in your region, with closed and open images, the ones that are open, number 1, and number 3 are interactable, and that you'll have a trigger in your code to make a loop or have tiles drawn on 4 for play to pick up. And that once they have been looted, their tiles are replaced with the tile images that represent the open chest. If you look at visual feedback, that the chest is already lit, and then have to do that anymore. Now, to get started, we first need triggers, so the code knows when the player is close to the chest. We cannot do that here in tiles editor, as tiles set one time, basically just textures together and nothing else. So we'll have those in separate scenes that we add to our map. So we go to scene, a new scene, put a new 2D scene, I'll change the time from node 2D into a area 2D. And area 2D will require also a pose shape so that it knows what area it needs to be techniques. So we should use circle shape, so you can even circle around our chest for protection. And you click on circle shape here, click on shape here, to areas fixed with your tiles. It has base tiles, base tiles, base tiles, base tiles, and also I'm renaming our nodes to group area 1, area 2, area 1, and then area 1 from finally. And also I'm adding these nodes to a group, and I'll pull that group areas. Now with that group, I'll use connect all areas, we'll add to map, we'll get connect all pretty easily. So with that done, we're now going to go over just the functions that you use on your time that are actually necessary to add this region, add a location on that. So let's do that. If you want to learn how to design a game, you use subscribe to the channel, okay, the volume, make sure you're using the video. Personally, I'm using source to be a new player, so you swap the RPG, and watching the game section, choosing those and push. You'll then use the to have the link down in the description below. That's me. For this tutorial, I'm adding script with those functions in on specific tiles, currently containing my chest. This time is the only thing chest that has to be, so that means specific time. You can't add this code to me, no matter what, might be better, but separate code to previous stories in series from this tutorial, we'll add it to this interact. So I'll add a script here. Now to protect this demo layer is to teach you 3 important functions on your time that you're probably using a lot. And the very important line there, I would say very immediate. So first up, we have to get used cells one ID, and we have to add ID number 2. Know which ID number your specific tiles are. When you open the tile set, you click your tile sheet, you actually have ID numbers like 0 to 9, those are ID numbers. Now this region of 4 tiles in a tile, that is ID number 6. So it means that not every one of these 4 tiles has their own ID, nor is this entire tile that has an ID. So that's important to know. Going back to the script, we have printed that so you can see that how you treat a regular tree is going to return an array of all the cells with the tile ID. And the cells, that is the grid on the grid cell. So you are on your tile using stack as 64 and 32, you don't need global coordinates. Now, because there are no global coordinates, that is why the map to go for. Basically what this takes is returns global position corresponding to the entire grid-based coordinates. So this is going to be grid-based coordinates, and the map to go, then turn into world coordinates. This is going to be taking a vector 2, and that's exactly being pushed by this function right, is tree vector. Now you also have, of course, you know which specific tile within that tile, remember 4 tests, this one using, and one knows which 4 you use, because you determine the chest is already open, number 1 knows which chest is already open, close texture. So you know which texture specifically used in that ID, but you get cell also cell coordinates. Now I know how to work all the time now. Basically what this function does is any tile that has a region in the tile set, so both tile and that. So it's a little bit confusing, but you just find it. What it does, it requires x and a y, and it requires all the tile cell coordinates. So it requires this, the grid-based coordinate and the global position coordinate. So we have the use of tiles to get the this is going to be all set tests. So we get the first test and then we get the vector 2, so we get x, add vector 2, vector 1, 2, 3, 1. Now let's take this is a function. So back to the so this one, so we add right here, we go right there, and we put this one right here. So this is first we retrieve all the tests, so the tests, so you see the right here, the grid-based coordinates 64, 4, you go with the zeros way up there somewhere. So 64 tiles down, this 45 returns to where we return to the straight line, so 64 tiles, let's say to the bottom right, and then we go 4 tiles down, so we'll be here and we'll go there. And that's how that grid-based works. Then we put the formula. It's going to go take the vector 2 times coordinates, so it's the exact coordinate tiles here, and we also see that the cell coordinate is 3.0. So I use that image, you see the array back to the left line, so this first one is the highest y coordinate, the y coordinate, so 4 over 21 there, each one we just there. So with 3 0 that means we go back to our tiles, we go here. So this is going to be 0 0, it's 1 0 0 3 0, it's the same thing. So that the coordinate is the x coordinate and the y coordinate is the position, that makes region. So this will be region 8, this will be 0 1, this will be 1, this will be 2, 1, this will be 3 1. So that's how you determine which tiles actually in your tiles externally used, and what you're using most of the apple area to easily figure out. As our code based on this now is going over, so let's paste that in here. So what happens first, we turn loop area, so we preload loop area 1, senior area 2, so we want to place that in there. And the functions we're going to get use test tiles all use, so we do the same rate as just had in the now we're going to forward, so we go over every single one. So every tile that you use in that as you treat the array vector 2 based on the grid cells. You're going to implement that first in if statement if the tile, the y coordinate is equal to either vector 0 or vector 2 0, which means that these 2 vectors based on our grid map that we retrieve one from these are closed tests. Remember the 0 1 and the 1 0 and the 3 0 are open. So first term is itself a closed test. And so then we're going to create a new variable loop area instance, and then we loop area that we see below earlier, so we're going to instance that. That means the position of that instance equal to map to world, and we can do the vector tile that's currently in this loop, that also based on use test tiles, that's how you use function. And then we add a tile to see and the tile has loop area instance over here. So with our visual position, now we should see all areas not add 2 rows, not all our tests, and if you function this all areas you also can lower in loop area 1 see itself to make a picture of it. This tutorial actually I'm sure will straight away. So
okay,
well, I'm going to select the mechanics of the mechanics from player. Then using that both player and using now using the times as I always say in camera area that's tough to think about how large players like that. I'll be using this using now as on the two very functions. These are only 2 functions that are connecting the area object. These are very different spaces for link and for link to test it works. Now you can also use connect to that using signals. So you go I'm going to be executing the moment of the loading. I'm going to go create a new variable can be maximum value using that's equal to get node. And then you go up and then one parallel and then down value using now that value using see all that's okay. I'm just going to go maximum value using so just remember in the loop area is group in the loop area is group. Now we're doing so we now go every area. But then to teach you 3 important functions on your tile that you're probably using a lot. And very important there, I would say very immediate. So first off, we have to get used cells one ID, and we have to add ID number 2. Now to know which ID number your specific tiles are. When you open the tile set, you click your tile sheet, you actually have ID number 1 here, 0 to 9, those are ID numbers. Now this means 4 tiles in the tile, that is ID number 6. So it means that not every one of these 4 tiles has their own ID, nor is this entire tile that has an ID. So that's important to know. Going back to the script, we have printed that so you can see that how your tree, or what tree is going to return an array of all the cells with the tile ID. That cells, that is the grid on the grid cell. So we are on your tile using stack based on 64 and 32, you don't need global coordinates. Now because there are no global coordinates, that is where the map to go for. Basically what it takes is return to global position corresponding to the entire grid-based coordinates. So this is going to be grid coordinates, and the map to go then turn into world coordinates. This is going to be taking a vector 2, and it's being pushed by this function right, tree vector. Now you also have, of course, to know which specific tile within that cell, remember 4 tests, that's one which 4 you use, because we'll determine the chest is loaded, remember one of the chest is loaded, currently have close texture. So we know which texture specifically used in that ID, but that means we get cell also coordinates. Now we know how to work all tile. Basically what function does is any tile that has a region in the tile set, so both tiles and that. So we're going to use function what it does, it requires x and a y, and it requires all tile cell coordinates. So it requires this, the grid-based coordinate and the global coordinate. So we have the use of tiles to get this one to be all set tests. So we get the first test, we're going to get the vector 2, so we're going to get x, add vector 2, vector 3, 1, 3, 1. Now let's actually this is a function. So back to the so this one, so we add right here, we go right there, and we put this one right. So what it does is first we retrieve all the tests, so you see the array here up to grid-based coordinates 64, 4, you can go with the zeros way up there somewhere. So 64 tiles down, and this one returns to where now we're going to go 64 tiles, so 64 tiles, let's say to the bottom right, and then we go 4 tiles down, so we'll be here and we'll go there, and that's how that grid-based works. Then we second formula, it's going to go take the vector 2 times coordinates, so it's the exact coordinate tiles here, and we also see that cell coordinate is 3.0. So that means that you see the array back to the left side, so this first one is the highest y coordinate, is the y coordinate, so 4 over 21 there, each one we just right there. So with 3 0 that means we can go back to our tile set, we go here. So this is going to be 0 0 is 1 0 0 3 0, so you see that it's the same thing again. So that the coordinate is the x coordinate and the y coordinate is the position, that makes it so it works region 8, and this will be 0 1, this will be 1 1, this will be 2 1, this will be 3 1. So that's how you determine which of the tiles actually in your tile region that you're going to use, and that's what we're using most functions there to add all areas to easily figure out. As our code based on this demo that we're going over, so let's paste that in here. So what happens first, we turn loop areas, we preload loop area 1 senior area 2, so you want to place that in there. And the right functions we're going to get use test tiles all use, so we're doing the same rate just had it now, but now we're going to forward, so we go over every single one. So every tile that you use in that as you treat by rate, array of vector 2 based on the grid cells, you're going to be implementing that first in if statement if the tile, the y coordinate and y coordinate is equal to either vector 0 or vector 2 0, which means that these 2 vectors based on our grid map that we retrieve one of these are two closed tests. Remember the 0 1 and the 1 0 and the 3 0 are open. So first term is itself a closed test. And so then we're going to create a new variable loop area instance, and then we loop area that we seen earlier, so we're going to instance that. Then we set the position of that instance equal to map to world, and then we do the vector tile that's currently in this loop, that will based on the use test tiles, that's how we use function. And then we add tiles to see and loop area, and the tile has loop area instance over here. So with the visual position on, now please make sure you see all areas not add 2 rows, not all our tests, and areas. When you function this all areas, you can offset, you can lower in loop area 1 seen itself to make a picture of it. We're going to do this tutorial, I'm going to show straight away. So to connect those traits, first of all, where we connect those two. First, select the mechanics of the mechanics from the player. Then using that both player, you can use this. Now, using this as I always say in camera area, that was perfect between how large players like that. I'll be using this to use this. Now, as on the two very basic functions. These are only 2 functions that are connecting the single area object. These are very basic, 2 principles for link and for link to test it works. Now, these examples, what you're using to connect to that, you're using this for signals. So we're going to go executing the moment of the node loading. I'm going to go create a new variable, the variable will be maximum value using this. That's equal to get node. And then we go up there on the variable, we go up one parallel up and then down variable using this. So So we're going to paint these 4 blocks, we turn this, this side board, and this side board, this side top is going to be unpainted, never match. So information, how every single bit necessary for this tile sheet, and back to you, see how it's supposed to go. Okay, that's it. These are all bit maps. If you want to redraw this, pause the video, go ahead, make a screenshot, make a cheat for yourself, this is already desktop, do it like it. Next thing up, you can copy this map, just go to the redraw land for the next one. What I'm going to do is I'm going to do all the time, I'm going to exact same all the time. I'll get this 3 for you, I'll give you the name, I know it, for the red line, yes. So we'll probably be able to top size. I'm going to go to the fourth map, we're going to select this tile set, we're going to go back to the bit mask, we're going to press the copy bit mask, we copy it. Now I'm going to grab select this one, go to the bit mask tab, and paste it on that, or I get that set for the next map, and we go for all 6 of them, and we'll run out. The last thing was drawing tiles, you know, getting tiles, different priority, you get a priority tab here. So for example, we got 20 tiles for a full drawn tile. If I really like this one for some odd reason, because we say, well, how about I get 20 of these? Well, how about we use 5 to 20, make it 5 to 24, that's it. Now, these tiles, there's 1 24 chance, this is the tile, 5 24 chance. You just better want to be 10, then, 10 there, now you can 10 for 4, or 3, or 3, and you can see, now you set priorities. The amount of tiles you start with is equal to tiles that match in the bit mask. So in the bit mask, we have 20 tiles in the top row, in 1 row, 4, 3rd row, 4 tiles, that's the tiles, so I want to pick up priority, for example, this one, you see, starts at 1 4, there's 4 tiles in that particular bit mask setting. So like that, you know, these 4, you want this one to appear twice as often, and the other ones, you change this to 3, so that one, you feel like you want it. Okay, well, the draw tiles, see how it works, you start out for yourself. Draw priorities, click on right here, and export, now for 4, red line, now draw 1, those are full tiles, and now you can animation. This tile changes 4, so now 4 of these, you see, now we can just and now it's the draw out, this tile, and also I can do control shift and draw straight lines, make a big block, use the fill up, and like that. Now it's like the manual, you can see all the randomizations being applied. You can recognize when you're priority, you can know how to redness, you can super fast tiles. For example, as I move to it, yourself, next time, this tile 2, go to symmetric, tile 1, 28, for tile set, I'm going to go back to the first time, I'm going to go back to this tile set, I'm going to save it, save as, we'll save it just right there, I'm going to end it, I'm going to change it itself, I'm going to load the second time with the new tile stress, for example, red line, course, better, okay, every single thing, you draw extra tiles over the first floor, you can see now, and you see overlap with merging each other with the same transparency of the board, so you can right glass patches on this first floor, made it. Now, play interesting. That was for short tutorial, I'll do short tutorials between my deep dive long series, I can do my channel, it's going to make a little bit more interesting for you, so yeah, if you want to switch out on this, so I will make sure you make it on the next tutorial. For your short tutorials, I think it's my text spreadsheet, so you can switch between different charts, and you want any mental source, between particles, and get like some lightning work, just hold on that, we'll see that, and then you can go through there. In the second part of the Godot series, we're going to on the scenes, and we have the full just before full hours. Then you so your friends have pretty much just
I am not your friend, you freak. I'm joking. Or am I? But I think that's it for today. Alrighty. That's the end of the